Good afternoon. This is Tuesday, September the 8th. Today in pre-calculus, or correction in geometry, we started chapter 2, and our topic today was inductive reasoning and conjectures. So I'll go and share my screen to the whiteboard and show you some of the types of problems that we worked on today. So the biggest thing when you're looking at inductive reasoning, what you've got is you're looking at a pattern. Like if I look at a group of numbers here, for instance, if I look at, say, 1, 2, 4, 8, 16, and I want to know what is my next number, then I can look and see basically that to get from the first number to the second one, I multiplied by 2. To get from the second one to the third one, I multiplied by 2, and so forth. So I would expect, if I continue that same pattern, that my next number would be multiplied by 2, and it would give me a 32, and so on. Now, here's the deal with inductive reasoning. You can't always be sure that the answer you're going to get is the right answer because, for instance, see, if you assume, like if I come down here and do 1 and I do 4, or let's do 5. So I do 5 and I do 9. If you assume that I'm using numbers, you notice I'm adding 4 to get from 1 to 5. I'm adding 4 to get from 5 to 9. So I would add another 4 and get to 13. But that assumes that I'm dealing with numbers. Now, if these happen to be like the first month of the year, which is January, and the 5th month of the year, which is May, and the 9th month of the year, which is September, then if I add 4 more months, that's October, November, December, so I am back to January. So the interesting thing about inductive reasoning is you think you know what you're working with, but you can always be, or you cannot always be very sure. When we have a problem here, if you get a sequence, generally speaking, they will tell you what the numbers represent. So if I had told you here that these represented months of the year, then you would have been able to go and do the pattern and get the correct answer of January, just like I did. Now, so some other types of problems, like if we come in here with a problem like the sum of 2 odd integers. Now, so you can, if I go back here, let me just erase that. All right, type it in right this time. Okay, sum of 2 odd integers. Now, so you can come down and look at, say, just some examples. Odd integers, 3 plus 5. What's it equal to? It's equal to 8, okay? I get 1 plus 7. What's it equal to? 8, okay? If I get 5 plus 9, 14. I get a really big one, 101 plus 213 equals 314. Now, if you'll notice, the answer in all of these situations is I'm adding 2 odds and I'm getting an even. 2 odds and I get an even. 2 odds and I get an even. So my conjecture here would be if I add 2 odd integers, then I get an even integer, and that would be a good conjecture because I can prove that mathematically. Now, in some cases, if you think, if I have a conjecture, to prove it, I have to work through with letters and not numbers. But to disprove a conjecture, all I need is one counterexample. So if I come in here and say, okay, I have a conjecture that says if n is an element, and that's what this symbol here means, an element which is a sideways e, it's an element of the real numbers then n squared is greater than n. Now, if you think about the number line here, here's your 0. If I take a negative number over here, if I square a negative number, I get a positive. So for any of these negative numbers over here, if I square the number, the square is greater than the number because the square is going to be over here. So that's okay in that region, right? If I come over here in the positive region, if I look out here greater than 1, like say, for instance, pick a number like 3. If I square 3, 3 squared is 9. So I would get all of that one. So that part would work, right? But then if I come in here into this part between 0 and 1, let's say I pick a half, right? Okay, if I square a half times a half squared is, or a half squared, I get a half times a half, which is 1/4. So in this region here, from open interval 0 to closed interval 1, if I square a number, I do not get a number which is bigger than the number I started with. So any of those points would be a counterexample to prove that this is not always the case, okay? Now, so if you look at your homework, this is a fairly straightforward section. I'll stop sharing here. If you look at your homework, you've got a couple of problems there that deal with basically looking at the pattern and figuring out what the next term is. So as usual, if you have questions, send me an email and I will get back to you on it.